Okay, so we're going to continue where we left off last time, which was we had given this vector, and we had found that its length was the square root of 1 squared plus 2 squared plus negative 1 squared, which is the square root of 6. And what we want to show, that the vector v over the length of v, which can be thought of as 1 over the length times scalar multiplication times the vector v, that this is a unit vector. And notice that it will definitely point, and so remark is that, and let's give this a name. Let's call this u. So remark, this vector u will point in the same direction as v, because the scalar multiple 1 over the length of v is a positive scalar. If we had a negative number, then it would point in the opposite direction, but since it's a positive multiple of the same vector, it will point in the same direction. Okay, so let's look at, so what we're looking at here is 1 over root 6, so u, which is this v over length of v, is this vector. So I have 1 over root 6 times 1 to negative 1, which I guess I can throw in the root 6 into the actual individual components. And we have this vector. And let's compute the length of u now. Well, what do we get? We get the square root of 1 over root 6 squared plus 2 over root 6 squared plus negative 1 over root 6 squared, which is the square root of 6 over 6, which is 1. And this turns out to be a general principle. So general principle that given any vector v in R3, or can generalize this to any n-dimensional vector space, I guess, but for us we're in R3. If you're given any, n-dimensional Euclidean space, if you're given any vector v in R3, and of course this is, or R2, or really any finite dimensional Rn, then the vector v divided by its length is a unit vector. And of course it points in the same direction as the original one. Okay. Let's just do one last exercise with this, and then we'll stop. So suppose the vector v is 2i plus 3j minus 4k, and we want a unit vector pointing in the direction of negative v. So if we want a unit vector pointing in the direction of negative v, then so if I had just v over its length, that would be pointing in the same direction as v. If I want it to be pointing in the direction of negative v, I simply take the negative of this. So the solution in one line is just this. So what is that? Well, that's a negative. And I'm going to write this now in the other vectorial notation, not as a combination of I, J, and K, just 2, 3, and negative 4, divided by, what is the length of this? Well, it's the square root of 2 squared plus 3 squared plus negative 4 squared, which is negative 2, 3, negative 4 divided by, so we have 4 plus 9, 13. 13 and 16 is 29. So this is negative 1 over 29, root 29, times 2, 3 minus 4, or negative 2 over root 29, negative 3 over root 29, 4 over root 29. Okay, so that's pretty much the end of 12.2. In the next video, we will begin 12.3.